Hello everyone, my name is Nestor, and today in my podcast I'll be talking about panorama cameras inspired by prey animals. I was interested in this topic because I have experience using panorama cameras for motorcycle riding. When recording a ride with a traditional camera or action camera, the camera only captures the direction it is pointing. If something interesting happens behind me or beside me, that moment can easily be missed. A panorama camera is different. It can record almost everything around the camera at the same time. After recording, I can choose which direction I want the final video to show. This experience made me think about an interesting question. Where does the idea of having such a wide field of vision come from? Our idea can be easily found in nature, especially in prey animals. Animals such as deer, rabbits, and horses often have their eyes positioned more toward the sides of their heads. This is very different from humans or other predators, animals of such. Our eyes face mostly forward, which gives us good depth perception, but it also means that we have larger blind areas behind us. For prey animals, being able to see a large area around them can be important for survival. They need to detect predators and that may approach from different directions. This wide peripheral vision reduces their blind spots and gives them better awareness of their environment. This is the biomimicry connection that interested me. A panorama camera is obviously not an exact copy of an animal's eyes, but both systems are trying to solve a similar problem. How can we collect visual information from as many directions as possible? I choose an example from my classmates. That's why I choose prey animals, because the interaction is easy to see and also connected directly to a specific anatomical feature. Similarly, panorama cameras use lenses facing different directions to increase visual coverage, like the side position of the animal's eyes. Most modern consumer panorama cameras use two ultra-wide fisheye lenses positioned on opposite sides of the camera. Each lens records a very wide image with the help of the design of the glass component. Together, the two lenses can capture almost the entire area around the camera. However, capturing the images is only the first step, and the camera needs software to combine them. The process is usually called image stitching. The images from the two lenses overlap slightly. The software analyzes this overlapping area and tries to combine two images into one continuous formatted picture or video of 360 degree. This shows why panorama cameras depend on both hardware and software. The lenses and sensors collect the visual information, while the software processes that information and creates the final image. Another question asked when I did my research was whether different lens arrangements or orientations could improve the stitching between the two cameras, and this is an engineering design challenge that is very important because the lens placement, more overlap between the images, the calibration and software, they all need to be designed properly to help make the transition between the two images less noticeable. However, panorama cameras still have several limitations. One problem is the image distortion, because while software tries to correct the original images recorded by the two units of ultra-wide angle cameras, correcting it too much from the software may contribute to the reduce of image quality. The camera needs an extremely wide field of view, but the wider the lens becomes, the more difficult it is to maintain completely natural-looking geometry. Future panorama cameras may improve this problem through better lenses, higher resolution sensors, and more advanced image processing software. And the usage of AI can also help identify people, buildings, roads, and other objects and correct distortion differently depending on what appears in the scene. And another problem is if an object is very close to the camera and located directly between two lenses, part of the object may appear distorted or even partially disappear. And the movement can sometimes make this problem more noticeable. And this is another reason why both camera hardware and software need to continue improving. And even with these limitations, panorama cameras have some important advantages. First advantage is its usage in action recording. With a traditional action camera, we need to decide where the camera should be placed and how it should be oriented before the start of recording. But there is no need to worry about all of these placement issues with a 360-degree camera. And this gives the user much more freedom during editing. And another problem that's valuable to notice about is the possible applications in entertainment area, like in sports for racing, basketball, football, skiing, or other sports. This could create a more immersive experience through the all-around environment recording. Instead of watching a normal flat video, viewers can look around the environment as if they were actually standing there through a suitable player that suits the 360-degree media format. And working on this project also changed the way I think about engineering design. At first, I mainly thought of panorama cameras as interesting photography equipment, but after my research, I started to see the connection between biology, optics, electronics, software, and visual art. To conclude, panorama cameras and pre-animals share an important idea, reducing blind spots by collecting visual information from a wider area. Pre-animals develop wide peripheral vision because it helped them survive, and with the engineers, they use wide lenses, sensors, and software to achieve a similar goal in modern cameras. Sometimes, engineering information does not begin by inventing something completely new. It begins by looking carefully at how nature already solves a problem and asking how we can apply the same idea in a different way. Thank you for listening to my podcast. That's all.